Hi guys, today we're going to look at differentiating exponentials and logs, and I want to remind you first of all of this wonderful property of e to the x. Why e to the x is so used so often is that it differentiates to become itself, and the number e was found by investigating this property of where exponential graphs and their derivative functions became very close to each other, and so it came about by really looking at that. And this natural number of exponential is used so much throughout maths, and it's so important. And an extension of that is that if y equals e to the kx, then dy by dx equals k e to the kx. And as we go through this topic, we'll understand why that happens, and we'll also understand how we can take that a little bit further. Now, so if that's what e to the x is, what about log x? So let's say y is equal to the natural log of x. How am I going to differentiate that? Well, let's think about how we can use what we know about its related function e to the x. So because they are inverse functions of each other and opposites, I could say that if this is true, then this is true. So if y is equal to ln x, then x is equal to e to the y. So if that's true, I can say that if I differentiate both sides with respect to y, so dx by dy, that would differentiate this with respect to y, which would give me e to the y. Now, it doesn't seem totally obvious, but dy by dx can be represented as a fraction. So if I took the reciprocal of this fraction and got dy by dx, I would get 1 over e to the y. And looking back at the beginning here, you can see that e to the y is equal to x. So dy by dx is equal to 1 over x. So you may not fully have followed that, but the implications of this are that if y equals ln x, then dy by dx is equal to 1 over x. And that's a massively important result when we come to integration. So I used the inverse function to say if this is true, then that is true. Then I differentiate with respect to y, and then realised dx by dy is only a fraction, so if I took the reciprocal of both sides, I would end up with that. And then going back to the beginning to say that e to the y was equal to x, I can stick that in there, and there we are. So, second important result. And following on from that, if you've got y is equal to ln kx, you can say, okay, well that's just the same as a product in here, so I can separate that back to an addition. So y equals ln k plus ln x. So if I was to differentiate them, this is just a number. K is a number, so ln k is a number. And if I differentiate a number, it just disappears. So y equals 1 over x. So maybe a counterintuitive thing here is that if you have y equals ln kx, and dy by dx would again equal 1 over x. That k doesn't give any significant difference at all. So I want to use this to help me with something else. What about if y equals a to the x? So a isn't a number. In particular, it's just any number. So where e was that specific number, 2.718, etc. This is any number. So I'm thinking about how might I differentiate that? Well, there's a little bit of a trick involved here. If I say that y is equal to e to the ln of a to the x, you'd appreciate that e to the ln are opposite functions of each other, so they cancel each other out to end up back there. Now, considering the laws of logs here, I can bring that power down. So I can say y is e to the x ln a. Or y is equal to e to the ln a x. And what you should see then is that is exactly the same as one of these. Because ln a is just a number, so that can be our k. So when we differentiate here, dy by dx is equal to ln a times e to the ln a x. So this bit here looking back is that there, which is what y is, but y is also equal to ax, so that is equal to a to the x ln a times a to the x. So the differential, so if y is equal to a to the x, then dy by dx is equal to ln a to the x. Now if that works for any number there, it must work for any number here. So if I said y equals e to the x equals ln e to the x, well, ln of e is 1. So the natural log of e is 1, so that would be 1 times e to the x. So this rule here works for that rule there. So that would surely mean that if y equals a to the kx, then dy by dx would equal ln a to the kx, or maybe k.